Welcome back. With this video, we are starting a new unit. We're starting Unit 7 about fundamental theorems of calculus and use substitution. This unit, like the last unit, will be very important for pretty much everything we're going to do in quarter 3. What else can I tell you about this? In your textbook, this unit finishes up chapter 4. There are only 2 sections in your textbook that we're going to look at in here, 4.4 and 4.5, but there is a whole lot of material in there. If I was the one writing the book, I would have made it take way more than just 2 sections because there's so much in there. We're going to spend this week and next week dealing with 4.4, and then the following 2 weeks dealing with 4.5. And then after that, I see you again in class. So, section 4.4 is going to start by talking about what we call the first fundamental theorem of calculus. There are 2 fundamental theorems of calculus. We're going to start by dealing with this first one. And here is our theorem. And this is the theorem that will finally make a connection between antiderivatives and definite integrals. This theorem is called the first fundamental theorem of calculus. It says the following: if we have some function f and it is continuous on a closed interval between a and b, and if capital F is an antiderivative of little f, then the integral from a to b of little f of x dx, the assigned area under f of x dx starting at a going to b, is going to equal capital F of b minus capital F of a, the antiderivative with b plugged in minus the antiderivative with a plugged in. Take a moment, get that copied down, please. Okay, so let me show you how we can use this. First example, I want to do the integral from 0 to 4 of x squared dx. I want to find the area under that parabola starting at 0 going to 4. And we saw how we can use the limit process to get there and all that. But now we're going to use this first fundamental theorem of calculus. What I need to do is I need to find my antiderivative. That's this capital F. Then I need to plug in 4 minus I need to plug in 0. Well, here's how I'm going to do it. The antiderivative of x squared is x cubed over 3 plus a constant. I'm going to say that that's my antiderivative. I'm going to put brackets around it with a 0 on the bottom and a 4 on the top, which is going to show that in a moment I'm going to plug in 4 minus I'm going to plug in 0. This is going to equal 4 cubed over 3 plus my constant minus 0 cubed over 3 plus my constant. 4 cubed is 64 over 3 plus a constant minus 0 minus my constant. The constants cancel. And that's a good thing. We shouldn't have a constant left in our answer. If we want to find the area under a curve, it wouldn't make sense to say that the area is like 2 plus a constant, because then it really could be anything. And in fact, the c's are always going to cancel. So in general, there's going to be no need to include them. Let me write that down. The c's will always cancel. So there is no need to include them. And finishing this off, my definite integral is 64 over 3. the signed area under that parabola starting at 0 going to 4, that signed area is going to be 64 thirds. This is the same answer we would have gotten had we done the limit process and all that stuff. But I think this is a little bit easier. And moving forward, we're going to use this first fundamental theorem of calculus to evaluate our integrals rather than using the limit process. The limit process is still tested on the AP exam, but if they give you just an integral and you have to choose how to do it, use this new first fundamental theorem of calculus. Make sure you get all that work copied down, please. We are not going to go through and prove where this theorem comes from. To actually be able to truly get to a proof, you need a lot more math than what we've done so far. In a college course titled something like Real Analysis, you would see the proof of this thing. We're not going to worry too much about the proof. We're just going to see how to use it. Let's try another one. Let's do the integral from -1 to 2 of x minus 2 times 3x plus 1 dx. I'm going to use my first fundamental theorem of calculus to do this. So I need to find the antiderivative of this thing. Plug in 2 minus plug in -1. Well, to get us started, I don't have a product rule for integrals. So how can you deal with rewriting this thing so you can find the antiderivative? I think we need to go and we need to FOIL. So that's going to give me the integral from -1 up to 2 of 3x squared minus 6x plus 1, so minus 5x minus 2 dx. Okay, so now it's in a good form. Now we're going to go find the antiderivative. And I'm going to write the antiderivative in brackets. And then at the end, I'm going to put a -1 on the bottom, a 2 on the top, which means I'm going to then plug in 2 minus, I'm going to plug in -1. See if you can find your antiderivative. Antiderivative of 3x squared is 3x cubed over 3. I'm just going to say x cubed. Then minus 5x squared over 2. Then minus 2x. And I'm not going to bother with the plus c, because as I told you over here, the c's are always going to cancel, so we don't need to include them only when we're dealing with definite integrals. If it was just a straight regular antiderivative, yeah, we certainly would need those c values. Now, I need to plug in 2 cubed, minus 5 times 2 squared over 2, minus 2 times 2, minus, I need to plug in -1, and I'm going to do that in parentheses, -1 cubed, minus 5 halves times -1 squared, minus 2 times -1. The rest of this is just arithmetic. I'd like you to finish this off and send your answer into Edpuzzle. Okay, 8 minus 5 times 4, that's 20 over 2. Oh, that's okay. That's minus 10 minus 4 minus -1 cubed is -1 minus 5 halves plus 2. Well, let's see. 8 minus 10 minus 4. I guess I could have done that, but I didn't. Whatever. We've got this. -2 minus 4 is -6 plus 1 is -5. Minus 2 is -7. -7 plus 5 halves, I believe, which will be -14 halves plus 5 halves, -9 halves, which just means there's more of this below the x-axis than above the x-axis. Your definite integral should be -9 halves. In your packet of papers, can you please take out the sheet titled 4.4 Area under a Curve with the Fundamental Theorem of Calculus. You're going to do a few of these. Number 34, I'd like to find the area of this region. Well, we need to set up an integral that will do this. And I think that integral is going to be the integral from negative 1 to 1 of 1 minus x to the fourth dx. That's all that I want to do. I want to see if you can go, use your first fundamental theorem of calculus, find your antiderivative, plug in 1 minus, plug in negative 1. So 1 minus 1/5 plus 1, oh, I shouldn't have done that. Why don't I just keep going with the parentheses for right now? Minus negative 1 minus, okay, negative 1 to the fifth is negative 1. I'm going to get some double negatives over there. This is 1 minus 1/5 plus 1 minus 1/5. I'm thinking 2 minus 2/5 or 10/5 minus 2/5. How about 8/5? Does that seem right? Oh, that's what I got the last time I did this. 8/5. See if you can do the next one. See if you can set up the integral for 36 and work through it. Should be the integral from 1 to 2 of 1 over x squared dx, and I hope you remember that the trick here is we need to rewrite it as x to the negative 2 dx. Negative 1/2 plus 1, I'm thinking 1/2 for that area. One more. Hopefully that's on the screen, I think. See if you can do 38. Cosine of pi is negative 1, so minus negative 1, minus 0 plus the cosine of 0, that's another plus 1. I am thinking pi squared over 2 plus 2 for an answer over there. I'll make the video pause if you need to get any notes down. So there's one other thing that I want to take a look at with this first fundamental theorem of calculus. Some problems that have a way of showing up on the multiple choice in the AP exam. Let's see here. Find the value of k such that the integral from 2 to k of x squared dx equals 19/3. So basically the area under the curve x squared, y equals x squared, from 2 to what would give us 19/3. Any thoughts on how we would do this? Well, let me go find the antiderivative. Antiderivative of x squared should be x to the third over 3 from 2 up to k. And I know that this had better equal 19/3. I'm going to plug in k cubed over 3, minus I'm going to plug in 2 cubed over 3, and it's going to equal 19/3. And you know what? My life would be easier if I just kind of multiply everything by 3 to get rid of those denominators. So I'm going to say k cubed minus 8 equals 19. K cubed equals 27. K equals the cube root of 27. K is going to be 3. If you actually integrated x squared from 2 to 3, you'd get 19/3 for an answer. Let me show you one that's a little tougher, and then that'll do it for this video. The integral from 1 to 2k of x minus k over x squared dx equals 15. And to get you started, I think we should rewrite it as the integral from 1 to 2k of x minus k times x to the negative 2 dx equals 15. You know what? See how far you can get. See what you can do with this one, and see if you can send in the k value to Edpuzzle. Okay, so when I integrate, I'm going to get x squared over 2 minus kx to the negative 1 over negative 1 from 1 to 2k. This has to equal 15. X squared over 2 plus k over x from 1 to 2k equals 15. 2k squared over 2 plus k over 2k, oh, that's actually going to be nice, minus 1/2 plus k over 1, that has to equal 15. Okay, so 4k squared over 2 plus 1/2 minus 1/2 minus k equals 15. 2k squared minus k equals 15, it's a quadratic. 2k squared minus k minus 15 equals 0. This can be factored. 2k plus 5 times k minus 3 equals 0, and I'm getting two answers. I'm getting negative 5/2 and 3. Actually, only one of these is okay. Here's the deal, and I would not do this to you on a test or quiz, or I don't even think in the homework. But here's the deal. If you plug in 3 for your k value, your problem will become the integral from 1 to 6 of x minus 3 over x squared dx. We had a rule that said we can only use the first fundamental theorem of calculus if our function's continuous. Our function's not continuous. It's got a problem at x equals 0, but that's okay because I am continuous between 1 and 6. So that's okay. But if you try k equals negative 5/2, you're going to get the integral from 1 to negative 5 of x minus negative 5/2 over x squared dx. This doesn't look great, so let me do some changes to this. First of all, I can switch the limits of integration. If I make my answer negative, I can say negative the integral from negative 5 to 1 of x plus 5 over 2x squared dx. I've got a problem at x equals 0, and this time 0 is in my interval. So really, the answer is only k equals 3. But don't worry so much about the end stuff. I wouldn't do that to you anywhere else. So this is our first fundamental theorem of calculus.